come some problems. Okay, what I'd like to do for you here is show you some examples. I'm not going to do all 4 of these. I'm going to leave 2 of them for you to try. So basically on this first one up in the top left, a to the negative third times a squared b to the fourth times c to the negative 1. We don't necessarily have to change the negative exponents to fractions yet. What I would encourage you to think about is that this is a set of powers that are being multiplied together, so we can actually add the exponents of the like bases. So let's look at this for a second. The a and the a. How many a's will we have? What's negative 3 plus 2? That's negative 1. So we're going to have a to the negative 1. And then we're going to have b to the fourth. And we're going to have c to the negative 1. So I'm just combining everything. I really only had to combine my a's. So in the end, what I'm going to have to do here, the b has a positive exponent, so it will stay on the top of the fraction, but the a and the c are going to drop down to the bottom. So I want you to follow what I'm doing here. There's b to the fourth all over, and a's exponent is just a 1, so I don't have to put anything there. And there's my c. So b to the fourth over ac. All right. The second one I want to do with you, and first of all, if you want to pause this and try the one right below it, this one, that's going to be similar to the one we just did. But remember, the big numbers, the big coefficients, do what it says. Just multiply 2 and negative 7. So in the next problem over here, I'm going to call this number 3, since that was 1, and this one's 2. On number 3, I'm going to go ahead and divide my 15 over negative 3, or at least simplify them. I notice also that my c's, I'm going to subtract the 5 and 2, and my d's, I'll subtract the 3 and 7. So I'm going to end up with 15 over negative 3. That is a negative 5. The c, I'm going to subtract 5 minus 2, so c to the third power. And the d's I will have as a negative 4. Now all of that's going to turn into, I'm going to put over here to the right of that, just a negative 5 on top of a fraction, c to the 3, and what's going to be on the bottom? That's right, d to the fourth. Alright, and that would be my final answer for that problem. Okay, I want you to try this fourth one, and you need to be very careful with the negative exponent right there. You could go ahead and flip the inside fraction and put this part on top and this part on the bottom, and what would that do to your exponent? I'll let you think about that. What would that do to the negative 3? Alright, pause this and take a shot at some of these. We'll talk about this in class. Okay, the next topic is the degree of a polynomial, but really we need to talk about what's the degree of a monomial, just one term. And you see that right here on this definition. So the degree of a monomial is the sum of the exponents of a monomial's variables. So if we know the sum of the exponents for that one term, then that is going to be the degree of that term. But here's what it says: the degree of a polynomial is the degree of the monomial with the greatest degree. So let's take a look at part A. 1/4 x to the fourth y cubed minus 8x to the 5. Well, it's pretty obvious that minus 8x to the 5 is going to be a 5, and they say that. The second term is the 5th degree. But for this one, you have x4 and y3. That's a 7. So in the end, the degree of the polynomial is a 7. So you want to find the monomial's degrees for each term. If there's more than that, you keep going, and you just take the one that has the largest. If there's a tie for the largest, you just put that down. Now the other question we have to answer here is, first of all, is this even a polynomial? And on part B, you discover that it's not. The degree of the square root of x, we don't know what that is. It's not a monomial. All right, that's not one of our. It's against one of our rules. And so plus x, that is to the first degree, and plus 4 is to the 0 degree. But because that's not a monomial, we don't even have a polynomial. So you would say there's no degree for this. Lastly, here's one that's a little different. You saw that when a polynomial is fully simplified, or a monomial, it cannot have negative exponents. But when you throw the exponents down to the bottom and make them positive, that makes it not a polynomial. So therefore, when you see negative exponents in the numerator of a polynomial, this cannot be a polynomial. Okay? So there's no degree for that. Okay, so here's a couple of examples. Find the degree of these two polynomials. The first one I'll do with you. I see an x squared, so that's a 2. I see 3x to the third, that's a 3, and 2x, that's a 1. So 3 wins. I've got a third degree. Alright, you try the second one. Pause this. Remember, if it doesn't have anything showing for that variable, it's a 1. I'll let you try that one, and we'll talk about this in class. Okay, this is a quick snapshot of some terms and maybe some definitions and examples that you might want to put down in your notes. So basically, guys, a polynomial is one or more monomials combined by addition or subtraction. You use plus and minus signs to join terms. You guys see how we have that going on right here, 3 terms right here. So what's a term? Well, each monomial in a polynomial is a term. So that same one that we just saw, it has 3 terms right there. A binomial just has 2 terms. A trinomial has 3 terms. So it goes on and on. When we get past trinomials, we just call them polynomials. But a polynomial, again, is it can just be a monomial. All right, just a fancier word. Okay, one of the more important items for this lesson, even though it's kind of a simple topic, like terms. These are 2 or more monomials that have the exact same variables with the exact same exponents, but they may differ by coefficients. For example, if I have 3y and I have negative 10y. They differ in their coefficients, but I have the y. If the y is to the 4th degree, now they're not like terms because they don't have the exact same exponents. But now it does. And I can combine them now. But what if the first one was an x? Now I can't. So you see, I have to have the same variable and the same exponents. All right, take note of that. And that will help you simplify polynomials and things in monomials together in different problems. Okay, so we've got 3 problems right here. These are not very difficult, but you might not have seen these in a while. I'm going to use on the first one. It's important for me to recognize that I've got a subtraction sign. Okay? So in using subtraction, that's only going to affect the right side over here. So I'm going to have 2x squared minus 3xy plus 5y squared minus 4x squared. Now that's going to be a plus 3xy, and that's going to be a plus, if I can get it written, 2y squared. Sorry about that. Alright, so now I'm going to combine like terms. I have a 2x squared on the front end right here, and minus 4x squared, that's going to be negative 2x squared. I have an xy right here, and I have an xy right here. So that's negative 3 plus 3, that's 0. I don't have to write that one. And then I have a y squared, and I have a y squared. So plus 5 on the left side, plus 2 on the right side, that's going to be a plus 7 y squared. And that's finished. So I simplified that using subtraction. I want you to try the next one down here. This is simply FOIL. Distributive property. Alright, but in trying the third one over here on the right side, I want you to be super careful because it's a little bit more than FOIL. You're going to have to take that times that, and then you have to do this one twice. And then you got to do this one to both of those. Alright, so let me erase, can I erase that? Yeah, let me erase some of those marks so that you can get busy on this problem too. But I want you to try this one, and I want you to look for like terms, okay, on that one. That'll be pretty key. All right. Pause this and give it a shot. All right, everybody. This is the end. So we've talked about adding, subtracting, and multiplying polynomials together in monomials. How do we find the degree of a monomial and a polynomial? So we'll talk about this more in class and extend this learning. But as we always say, in the end, we want to flip and not flop this lesson. All right, come to class with any questions and be ready for any type of quiz we might have. All right, bye.